to tour our STEM Week program as well as see some of our new probeware from our Massachusetts Life Science Center grant in action. So this grant we were able to use to purchase almost $200,000 of Vernier probeware, which is going to allow our students to take measurements in all fields of physical science, chemistry, biology, in order to gather authentic real-world data to perform investigations.
So these are various Vernier probes. And each probe tests for a certain measurement in the environment or in an object. So for example, this is a voltmeter, and we have it hooked up to a solar cell, and we'll turn on this light, and when it starts charging, this voltmeter will test the voltage or will report the voltage that this is collecting. Over here we've got a light and color meter, which will tell you the intensity of light and the spectrum of light that's being shown at these various sensors here. This over here is a temperature probe, and you can use it mostly with liquid, although solids do work, but not as well. So you would stick it into a beaker, and you can test the various temperatures of the substances that you're using in an experiment or activity. And then this last piece over here is a magnetic sensor, so it senses magnetic fields in objects.
So we're going to take a tour of our STEM Week programs, and our professional development partner, the Wade Institute, has provided us through the Mass Pioneer Valley STEM Network with a wonderful challenge where students are engineering and creating solutions to a flood. So we're going to get to see that. We're also going to take a tour of a science classroom where students are completing an investigation using the probeware for the first time. For the students, it's going to give them access to authentic investigations, which means they're going to be using real data that they've collected through investigations they're leading. So we're going to put the science and the engineering into the hands of the students, put them in the driver's seat of the investigations. So develop them both as scientists and engineers who are able to use this real data to solve problems, and also as leaders in the classroom who are able to take the reins of their learning and become independent scientists, engineers, and learners.
We each had to build a shelter to protect 15 little bees or people from intense, like just a spray bottle and a fan. So, and if you kept all the people in, you're good, and kept all the people dry. And then after that, we built these, which are the boats or like escape boats, basically.
So they've been doing a lot of hands-on stuff. So we're using a hurricane activity. So students are building shelters for people, which in this case were little beads. So they built some shelters, they built some escape vessels for areas that would have been flooded by the hurricane. And then they started looking at renewable and non-renewable energy sources to pump water from like the areas affected by the flood. But it's really cool. The kids get to do this really cool like hands-on engineering and work with each other, and they came up with some brilliant stuff.
But these ones, this is a battery, and it will like suction it, and it will transfer the water from here to there, and kind of filter it like this. So that's what a lot of them do, and that's what these ones can do.
That's cool.
I'm so proud of these guys. They do phenomenal work. They're great kids, and it's important that they get a chance to really get the hands-on activities and to do things where they can actually just kind of dive in and experiment and design and redesign, and it's really cool to see how proud they are of their final product.